All right, guys, if today is the day that you missed, rejoice, because for the first time ever, when I say this video is going to be short compared to the other ones, this video is going to be dramatically short. So lesson 2.3 really is kind of a discovery lesson. And if you were not here in class, I want you to go through the lesson and follow the instructions. I want you to do what it tells you to do on your own. I don't want to walk you through it here in the video. I'm not planning on walking you through it in class because it's something that I want you guys to kind of go through and discover as you are doing it for yourself. That being said, there's a few things I want to show you on the calculator, and that's what this video is going to be. So on your calculator, the lesson is going to tell you that a calculator cannot find, well, some calculators can. The calculators allowed on the test can't find a derivative directly. You can't say, hey, what's the derivative of e to the 3x squared minus 27x to the 1/4? It won't find that derivative for you. But what it will do is evaluate a derivative at a certain point. Okay, so for example, say I have the equation 3x cubed. Let's say that's my function. If I want to find the derivative of that function at the point 7, what I can do is I can hit math, and then there's a list of things here. If you look down at number 8, it says NDERIV. That's derivative. So if I do math 8, it gives me this formula to kind of fill out. Now, on your calculator, the X under the D might not be there. You might have to put that in yourself. So put in that X, and then I'm just going to put in my original function, 3x to the 3rd power. And then it asks me, what point do I want to evaluate the derivative? So 3x cubed is my original function, right? And let's say I want to know what the derivative is at 7. So I hit enter, and it gives me a value, 441.000. That is my value, my estimated value of the derivative at x equals 7. Okay? Use that. You can find the derivatives at specific points on this assignment when it tells you to. There's going to be places where it wants you to do things by hand. You need to make sure that you do it that way. But a lot of this assignment in this lesson is using the calculator to do a little bit for you. 2 more things I want to show you. Y equals. I'm going to do that same function, 3x cubed. And I'm going to graph that function. So here's my function right here. There's 3x cubed. Now, if I want to do the same thing I did, if I want to evaluate the derivative, I don't have to go back to the main screen. From this screen right here, I can find the derivative of a point. I can say second calculate. It's the trace button up there. Second calculate. Notice number 6, dy dx. That means derivative, right? So if I want to calculate the derivative of this function right here at the point 7, I just hit that, what I just did, and then I hit 7, and I hit enter. And it tells me right here at the bottom on my screen, dy dx of y1 is 441. Isn't that what we got before? 441. So you can evaluate it on the graph, or you can evaluate it algebraically in the main screen. There's one other cool thing that you can do in y equals. You can graph the derivative, which if you think about it is pretty powerful. I can graph the derivative. And here's how I do that. I'm going to go to y2, and I'm going to hit math 8. This is the derivative, right? So I want to graph the derivative of 3x cubed. And instead of putting a value in right here, I'm going to put an x. I'm going to graph the derivative everywhere. So when I hit graph, yours won't go as fast as mine did, but look at my graph. The derivative is in red, which kind of makes sense, right? If I were to use my shortcut and take the derivative of 3x cubed, isn't that 9x squared? So I should have a parabola, right? Well, there's your parabola right there. What's cool about this is technically now I can evaluate any point I want. I can say, hey, if I just hit 8 right here, I'm not going to calculate. All I'm doing is hitting 8 and I hit enter. It tells me that y1 is 1,536. y2, that's the derivative, is 576. So I can just keep plugging in values. I can say, hey, what's the value at pi? Oh, look, y2 is 88.8264. That's going to be pretty powerful on this, on these notes, and it's going to be pretty powerful on the homework as well.